Welcome to This Explainer. Today, we're diving into something I find absolutely fascinating, the biological masterpiece of hazel eyes. It's a trait that quite honestly completely defies the standard crayon box. You know, your eyes don't just see the world, they actually carry the echoes of mountains crossed by your ancestors and languages lost to time. But if you have hazel eyes, well, your story is even more mysterious because your gaze doesn't just settle, it shifts. It's a real-time collision of physics, genetics, and ancient history, all happening right there inside your iris.
Now, you might think they're pretty common, right? I mean, roughly 18% of people in the US have them. But globally, if you've got hazel eyes, you belong to a seriously exclusive club, making up just 5% of the human population. For centuries, this trait was so baffling that it wasn't even classified as a distinct color. Scientists basically just scratched their heads and called it an intermediate mistake on the spectrum. It didn't fit neatly into the brown category, it certainly wasn't blue or green, so it was kind of just written off as a genetic fluke. But today, we know for sure they are an absolute marvel of evolutionary engineering.
So let's actually solve this mystery. When we look at the iris up close, like under a microscope, we really have to ask ourselves, are hazel eyes some kind of genetic mutation? Are they a perfect blend of colors, or are they just a massive optical illusion? And why exactly does this chameleon-like eye color seem to just vanish entirely in some populations only to flourish in others?
All right, let's get into Section 1, the physics of hazel, light, canvas, and paint.
Think of the eye like a living art studio. Step 1 is your canvas, and it's actually structurally blue. Just like the sky above us, there is absolutely zero actual blue pigment in a light eye. Instead, it's this clear web of collagen that scatters light. When light hits that web, the longer wavelengths pass right on through, but the shorter blue wavelengths, they hit it and scatter, bouncing right back at whoever is looking at you. It's a process called Rayleigh scattering. Then, for step 2, we bring in the paint, a transparent, yellowish gold pigment called lipochrome. And finally, step 3, we get the masterpiece, the green illusion. Mixing that scattered blue light with the yellow pigment creates green. So technically, that vibrant green and gold you're seeing, they don't even exist as solid pigments. It's literally pure physics.
But here's the catch. This yellow pigment isn't spread out evenly at all. It forms what we call a pupillary burst. It's this gorgeous mosaic hugging the pupil that kind of just dissolves outward into streaks of green, gold, and sometimes even gray. And because hazel is structural rather than a solid flat color, it reacts to its environment in real time. White sunlight at noon amps up that blue scattering. Warm indoor lighting, that's going to reflect the gold. Even throwing on a green shirt can trick the observer's brain into enhancing those specific wavelengths. Your eyes are literal mirrors reflecting the world around you, which is exactly why they never seem to look the same way twice.
Moving on to Section 2, the genetic dimmer switch, decoding the 16-gene symphony.
Okay, remember high school biology? We all learned that old Mendelian model of genetics. You know, drawing those little Punnett squares, learning that eye color was just this simple, frankly kind of boring binary switch where brown is strictly dominant and blue is strictly recessive. If that old model were actually true, two blue-eyed parents could never ever have a hazel-eyed child. But modern genetics? Yeah, they threw that totally out the window. Enter the new polygenic model. Eye color isn't some solo act. It's a massive symphony of at least 16 interacting genes working together to create these incredibly diverse intermediate colors.
Right at the center of this symphony, we have two main conductors hanging out on chromosome 15, OCA2 and HERC2. The best way to think about them is to imagine OCA2 as a pigment factory. It provides the raw instructions and the actual machinery for producing color. HERC2, on the other hand, is the factory manager's dimmer switch. It dictates exactly how much melanin that OCA2 factory is allowed to churn out. If that dimmer switch is cranked all the way up, you get dark brown eyes. All the way down, you get blue.
So, thousands of years ago, somewhere near the Black Sea, a mutation happened. It basically created a glitchy medium switch on that HERC2 dimmer switch. In hazel eyes, that switch is super unstable. It stops halfway, creating that heavy burst of brown right around the pupil, while inexplicably leaving the outer edges entirely clear of melanin. This glitchy medium setting interacts with a whole bunch of other fine-tuning genes that dictate things like collagen density and lipochrome levels. And that is what makes every single hazel eye as uniquely distinct as a human fingerprint.
Which brings us to Section 3, the chameleon mood ring, biology and the nervous system. Okay, we need to bust a really persistent myth right now. Your eyes do not actually change pigment when you get emotional. I mean, you can't just rapidly produce melanin on demand because you're angry. Instead, your autonomic nervous system physically alters the landscape of your iris. During a fight or flight response, your pupil dilates widely. Imagine an accordion compressing. That iris tissue gets pushed outward, folding up so that the outer green ring suddenly appears much denser and richer. But when you're calm or maybe sad, your pupil constricts down to a tiny dot that stretches the tissue inward like a rubber band, revealing the full brown starburst at the center. So your pigment stays exactly the same, but that mechanical movement, it broadcasts your nervous system's state right to the world.
Let's look at Section 4, the price of hazel, survival and vulnerability.
Now, having this incredible aesthetic trait does come with a very real biological price tag in the game of survival. Because hazel eyes lack a full dark melanin shield, they offer significantly less UV protection for the delicate retina inside. This makes hazel-eyed folks highly prone to photophobia. That's that frustrating physical sensitivity to bright sunlight or harsh office lights that makes you want to immediately reach for your sunglasses. There's also an increased risk of ocular melanoma, which is a rare type of eye cancer. But there is a fascinating hidden upside here. Researchers have found a strong correlation between lighter eyes and a much higher pain tolerance. They even experience noticeably less anxiety during things like childbirth. The exact genes determining your eye color are intimately linked to nervous system development, which offers a pretty surprising biological shield to offset those physical vulnerabilities.
On to Section 5, a map of ancient migrations, the crossroads of DNA.
Let's rewind the clock about 7,000 years. Humanity essentially had two totally different evolutionary strategies playing out at the same time. Up in the cloudy, sun-deprived climates of northern Europe, blue eyes were developing to help absorb much-needed vitamin D. Simultaneously, in the sun-drenched regions of Africa and Asia, brown eyes were thriving as a crucial UV shield against the harsh sun. Then, during the Bronze Age, the world began to move. The Yamanaya people migrated outward from the vast steppes, mixing these light and dark eye genetics over centuries. Hazel eyes are literally the ultimate borderland trait. They are the physical, enduring evidence of ancient hunter-gatherers colliding and mixing with dark-eyed populations.
And you know, this completely shatters that Western-centric misconception that light eyes are exclusively a European thing. Not true at all. Hazel eyes cluster heavily in the great genetic melting pots of history all across the globe. We see them prominently in the Iberian Peninsula, blending Celtic, Roman, Germanic, and Moorish lines. We see them all over Brazil's incredibly diverse mix of European, indigenous, and African heritage. And critically, across the Middle East and North Africa, all along the ancient Silk Road highways, hazel eyes are a defining feature among Berber tribes and populations deep in Iran and Afghanistan.
And really, that is the poetic truth of our genetics. As the world continues to globalize, blending us all into one highly connected human family, these crazy complex polygenetic traits required for hazel eyes, well, they might actually go underground for a bit, hiding out completely unseen behind dominant brown genes. But they will reemerge, totally unpredictably, across every continent. It's like a rare genetic diamond popping up out of nowhere and a beautiful living memory of exactly where we came from.
So we're going to wrap up this explainer with a question for that 5% of you carrying this masterpiece of a genetic lottery. What does your hazel look like? Do you have that brilliant sunburst of gold, the dark outer ring of charcoal, or do your eyes shift dramatically with the seasons and your moods? The next time you pass a mirror, take a really close look. You aren't just looking at a color. You are seeing thousands of years of human history looking right back at you.